All right, ladies and gentlemen, boys, girls, fellow Homo sapiens, I told you I'd try to do the practice problem from this, the example problem. This would be overcoming friction, additional problem E. This is the one that's already done from you. I'm just going to walk you through it. Okay, so a very large telephone was constructed by the Dutch telecommunications company, was demonstrated in the Netherlands. Suppose this telephone was towed a short distance by a horizontal force equal to 8,670 newtons, so that the telephone's net acceleration is 1.30 meters per second squared. Given that coefficient of kinetic friction between the phone and the ground is 0.120, calculate the mass of the phone. So again, what do we know? We know gravity equals 9.81 meters per second squared on average. We know the applied force was 8,670 newtons given. The net acceleration is 1.30 meters per second squared forward, whatever direction we decided they were going. Mu sub k is 0.120. Should probably write that in, forward. Well, assume forward and forward for both of those. Those are vector quantities. We do have a direction, it's just assume forward. We want to find the mass. Well, I just drew a big telephone, old style. I don't know if this is the right way, but this is what they did. Could have been just the receiver, don't know. But we have a force, normal force, force due to gravity, a frictional force, and applied force. Those are our forces. This one is fairly straightforward in the fact that all of the forces are acting along the axes we're going to choose. Positive y is up, positive x is forward. Okay, looking at this, we're going to do the same thing we've done in the past. Okay? We have the sum of the forces in the y direction are 0. Okay, there is no acceleration in the y direction, but that's equal to mass times the net acceleration in the y direction. Well, mass is not 0, so it must be the acceleration is 0. What does the acceleration 0 mean again? It means it is either not moving or it's moving with a constant velocity. Okay, and this is equal to then the normal force minus the force due to gravity. Because there are no weird angles involved or no forces acting in the normal force direction, the normal force is simply equal to the force due to gravity. Normal force is equal to mg in this case, because it's equal to the force due to gravity. Well, now we want to look at the forces in the x direction. The sum of the forces in the x direction is the mass of the system times the acceleration in the x direction. We were given that. Okay? This is a net x, the net acceleration in the x direction. Okay, and that must equal then the applied force minus the frictional force. In this case, the frictional force is a force due to kinetic friction. List that as F sub k. Okay, so that is equal to, now we know that F sub k, or any frictional force, is mu times the normal force. So we know that. So we know the mass of this object times its net acceleration must equal the applied force minus mu sub k F sub n, which is simply mg. We want to find m. Well, we need to isolate the m's then. Well, this is the applied force minus mu sub k, normal force, again, which is simply mg. So I need to isolate this over here. So I have the mass times the net acceleration plus mu sub k times mg must therefore equal. We've subtracted that, must equal the applied force. Isolate the m, pull it out, we get m times a net plus mu k g must equal the applied force. Pretty simple then. M must equal the applied force divided by a net, there in the x direction, plus the coefficient of friction, u sub k, g. Okay, at that point, I believe, I agree, oh yay, I agree with exactly what's on the page. Then we simply plug in the numbers. End up solving, you get something for 3 sig figs. This number had 3 sig figs to begin with. My net acceleration plus mu k times g will end up being good to the hundredths place. They had 3 significant digits between each of them. When you multiply them together, you get that 1.18. So we have 8670, okay, a net 1.30, okay, plus 1.18. When we ended up multiplying this, we got good to the hundredths place. Add those two together, you're good to the hundredths place. Guess what? That's 3 sig figs, 3 sig figs. My final answer should have 3 sig figs, which is 3.50 times 10 to the third kilograms. It's a mass. This is force. Force is newtons, which is a kilogram meter per second squared. Each one of these should be in meters per second squared, leaving me in kilograms. Okay, hopefully that was fairly straightforward. Hope you're having a great day. Drive fast, take chances, doing appropriate things to people your own age. Stay safe. Miss you.